It doesn't require license, right? So we don't need to apply to the government to get a frequency, right, spectrum or a frequency, right? Now, what is the rationale? Now, this is from textbook, right, from lecture notes. It's a technology that multiplex or combines, so multiplex is combined, multiple optical carrier signals on a single fiber, right? By allocating different wavelengths or colors of light, right? That's all. So given that light of different wavelengths are transmitted on individual fiber optic as shown in the figure, right? By means of a freehand sketch, draws a spectrum. Now, what you have to do, you draw an axis just like that, and then you place one following the other, right? So then the highest one, then the middle one, you keep a distance between them, the small one, then the third one, then the fourth one, all of them in a single diagram, one after the other, right? Now, I have an online lecture at 5. I need to hurry up because I made a mistake, right, unintentionally by covering this thing, right? Now, assume that you have access HTTP here on a web server, right? Listening to port 80. Explain fully the meaning of HTTP nature org flowers rose HTML, right? Now, this is what we did in the lab, right? Of web, when we did web, right? Now, what is HTTP? Is Hypertext Transfer Protocol, right? Is the application protocol used for web, right? For distributed collaborative hypermedia information system. That is for web communication on the web, right? Now, FreeW is the server name of the website, right? It's a canonical name. Nature.org is a domain name, right? Flowers is a folder in which rose.html is located, right? Now, rose.html is a resource that we are looking for, right? It can be also, it's not index. Index is a first page, is a home page, but it's not index.html, it's something else, right? So is a TCP connection of the web server maintained until you close your browser or not? Justify your answer. Now, this is a very beautiful connection. We did web, right? Small. Now, this is TCP users, right? Web users TCP, ultimately, first DNS, first UDP, then. Now, suppose you go to a browser, right? You type this thing and you get something on the screen. Is this connection maintained, right? If you go from here and leave and go and back, or is it only when you close, right, that it goes? Do you get my point? Let me read the question again. Is a TCP connection to the web server maintained until you close your browser or not? So only when you close it goes or not? What do you say? Right? What do you say? No, it's not maintained. You see, TCP involves what? First, connection establishment, then data transfer, then connection termination. You see, once this page appears and everything there, image, text has appeared, the connection is automatically closed, right? It's not that you have to wait until you close the browser. Otherwise, what people will do, if they want to submerge a server with millions of requests, everybody will connect to the server and leave, right, the browser unclosed, right? So then the connection will be maintained. No, the browser won't be accessible. The server won't be accessible. No, it's not this way. TCP involves 3 phases, right? First, connection establishment, data transfer, right? And then connection termination once whatever you want has been shown on the screen. Yes, well, yesterday you mentioned rationale. Is it about the problem itself? Yes. Yes, this is it, right? Rationale is the problem it is addressing. It's not functionality. It closes when all the packets, that's right? When all the packets has been received, right? That's good. You see, I have another class at 5. By mistake, I've done something else. You should have pointed out to me next time. Just point to me, look, sir, we are not, this is not what we are expected to do. You see, I've taken 214 by mistake, which is different from this one. You see, the questions are not the same. Now, okay, let's do one first now. Now, this is very easy, right? It's all about IP addressing scheme. Now, just see, here you need to know about the classes of IP address, right? So write down the network ID and show the host ID, right? So first one, network ID is class C, right? So it's what? 213.67.13.0, right? Host ID, you underline the 21 port. Don't show it, don't write it. Just underline it and show below it, this is the host ID. Second one is class A. So it is 54.0.0.0, right? Host ID is, you underline below it, you write the IP address and underline 215.89.16, right? The third one is again class C. It is 201.17.263.0, host ID is 84, right? The last one is class B. So network ID is 132.94.00, host ID, you underline 158.76, right? This is okay? Is it okay? So we have questions 6 and 7 in tutorial 5 as well. Let me see. Oh, I forgot. I missed it. I'm sorry. Right. So let's get back to this tutorial 6. Tutorial 5. I'm sorry, somebody has pointed. I missed 2 questions. Right. Let us do it. So what is a commonality in amplitude modulation, frequency, and phase modulation? Right? They all use what? Can somebody say? What is a commonality? It's very simple. Don't say they all modulate. No, that's wrong. What do they all have? They all have a carrier signal. Yes, they all use an additional signal. Not only the intelligence, but a carrier signal, right? Amplitude uses 2, frequency uses 1 more, right? But they all have one, a carrier signal. So in amplitude modulation, how is a series of 0 that is being received treated, right? It is a loss of connection, right? It is taken as a loss of connection. Now, network A uses a shared cable configured in a bus topology. Station gain access to the shared medium using slotted Aloha protocol, right? Right. Why should transmitted frame be of equal size when using this protocol? Right. Now, why? Because if we have bigger frame, right? We have bigger frames, they will take more than 1 slot. They will need more time to traverse the medium, right? And they will also occupy the channel for a long time. And if we have smaller frames, right, then it is a wastage of the slot because they will take only part of the slot because the slot represents time, right? So this is why we have, right, frames of equal size, because frame of equal size will ensure a consistent transmission delay, right? So with slotted Aloha, stations are allowed to transmit at slot boundaries, right? What is the length of a slot equivalent to? The length of a slot is equivalent to what? Is a time taken for equal size packet or packet of equal size, right, to traverse the medium. Or it is equivalent to the transmission delay of the packet. That's all. You can say even transmission delay of the packet, right? So propose a way to determine the length of a slot. So you can use round trip delay just as we did before. Take round trip delay, divide by 2. Perform several times, use average, you get it, right? Or you start a timer when you're sending the packet at the end, right? Then when the packet reaches the other end, you stop the timer, right? And then you do this multiple times and find the average, right? This is also good. Now, there's something that you will learn later. It's known as echo packet. You can also use an echo packet. An echo packet goes to a destination and come back, right? But this we will do later, right? There's another type of packet known as echo, right? This is also accepted, right? Right? Echo packet is not acknowledgement. The packet itself come back. It goes there and come back without acknowledgement. It's the same packet. You can use that and divide by 2 and make what and do the averages. Then this is also acceptable. Note this down. Echo packet can also be used. This, but we have not covered echo packet yet. This is why, right? I'm not telling you about it. Now, give me 1 minute. I'll inform the other batch that we have. I have a tutorial. I will start later. Just give me 1 minute. Now, okay, let's go back to tutorial 1 now. Consider the following non-default subnet masks to which class they pertain. Right? The first one, this is too easy. The first one, you have 3 values. This B, second one, A, right? Third one, C, right? So write down the following in CIDR notation, right? Now, in CIDR notation, you should translate this into bits. Now, 255 is 8 bits, so 224 you have to do. I think 224 is 3 bits, right? So the first one is 150, 60, 70, 180 slash 19, no? Right? If it's wrong, you tell me. Second one, 75 subnet mask this. Now, this subnet mask is 8 plus 3. 8 plus 6, no? 14. So 75, 80, 85, 90 slash 14, right? The last one is this. So 192 is the first 2 values. Ça veut dire 8 fois 3, 24, 24 plus 2, 26. Right? So it's 100, 200, 100.50.25 slash 26. Is it okay? Is it okay for all of you? Yes? Right, okay, good. Now, find the broadcast address for each of the following, right? The first one you have to do, right? You remember I showed you how to do, right? You have to do it for the first one, right? Because using, you take 256 minus 240, then do multiples, right? Then it should be above, then -1, right? When it is default subnet mask, it's easy, right? So I don't know the answer. Type the answer for me. Allô? Qui veut détecter? Oh, ok, allez, allez. Oui. Now, type the answer for me, anybody? The first two answers, type and let us see whether it's good. Now, is it good for the first one? Communicating has type? No. No, it can't be that, the first one. It's 240. The first one, is it? I don't know. It's 255, 255. Maybe. I'm sorry. Maybe it's good. It's good? I think it's good though. It might be good. Yes. Is it okay? Somebody else compare and type yes or no, please. I'm in a hurry. Quickly. Is it okay? Yes. Don't type the same thing. Just say yes. Okay? It's okay. Yes. All right. The second one. So the second one is, I don't know the answer. Type somebody. Please do quickly because I have to fetch my daughter. Is it okay? Yes. Attendez, il va être bon là. Parce que moi, je peux trouver les boubines 31 même. It seems good. Now, the third one also you have to do because nothing is default here. So type the third one, 221.76. This one might be the 84. It might be 62, 61 or 63, I don't know. Type the third one, 63, huh? Anyway, okay. Right. You see, you practice, that's very good. Now, calculate network address. Now, network address is performed by doing the binary, right? By performing bitwise AND operation by the subnet mask and IP address, right? IP address and subnet mask. Now, when you have 255, you don't need to do anything. The first one is very easy, 254.0.0.0. The second one you have to do, right? I think it might be 24.144.0.0. Is it okay? Yes. Now, third one, this is default, this is it, 132.94.0.0. Fourth one you have to do because non-default, right? So it's 187, 201, then what value? 158 avec ça. No, I have to compute it. What is the value for the third one, please? For the fourth one, fourth. Somebody type, is it okay? The fourth, 100 it might be right. So it's 187, 201, 156, 0, right? Now the next one. This is default. This is easy. 213, 67, 38, 0. This one you don't have to compute. You just take the network host ID port, set it to 0. The last one you have to do, right? Between 224 and 256. What it will give? Is it 24? I don't know. It might give 24 itself, this one. I think it might get from 24. So it's the same. Right. Now, 3 stations are connected to a common Ethernet hub. The IP addresses are this and this and this. Determine which among them can communicate with each other. So here, for stations to be able to communicate on the same subnet, you have to work out the network address. Those which have the same network address can communicate, right? So this one, I have worked it out, right? Only one. So the first one, network address is 200.100.50.64. The second one is easy. No, this is 200.100.50.0. Third one, 200.100.50.128. And fourth one, 200.100.50.0. Is this right? Please confirm, was it right? This one I did work out because I thought it will take too much time for you to do it. So which one has common? It's station B and D. So only B and D can communicate. Is it okay? B and D communicate? Is it right? Yes. Okay. Now, tell me, please, because I have scheduled a next tutorial and I have to pick up my daughter. She's alone on the road there from tuition. Now, did we complete everything, or we have missed something in the tutorial? Hello? Just tell me whether we have completed. We have completed now. We have not missed anything. I'm sorry, I made a mistake with the date. I've done for 214 instead of 224. Anyways, let it go. It's too late now. It's okay. Now, there will be, later today, I will give you enough time. I see that initially there was 68 and finally 79. Many came late just to get an attendance. That's their problem, right? Now, those who came the 68, which were always present there, right? Right, and even others one, if you cheat, that's your problem, right? Right, there will be an attendance sheet, you write your credentials there, right? So we have completed everything for the 68 who were present at the beginning till the end to be present, right? The others who just joined in is just for attendance, that's okay for you, right? So goodbye, right? That's all. So we still have to do, oh, there are more? Oh my God. So a company uses class A IP addresses if the 18 last bits are used, find the number of host per subnet, right? Now, so the default, the subnet mask is 255. So then 18 last bits. So you will have 1, 2 zeros, and the rest zeros, right? So number of hosts per subnet is what? 2 to the power 18 minus 2, right? So host bit is 6. Number of subnets is 2 to the power 6, which is 64. Right? Is this okay? So non-default subnet mask will be 255 to 5200. Is it okay? Please confirm because I'm in a hurry. Yes? Okay. Now, a university is deploying class B IP addresses. Please. Now, non-default subnet mask. This is host bit. So you have 255, 255, 31, and the rest zeros. So the number of subnets is 2 to the power 3, which is 8. Number of hosts per subnet, how many zeros are left? 8 plus 5, 13. So it's 2 to the power 13 minus 2, right? So this you simplify. Non-default subnet mask will be 255, 255, 31, c'est 224.0, no? 255, 255, 254, 224, 0. Is it okay? Yes? Okay. I'm sorry, I'm getting late, right? So laptop this, then subnet mask assumes that located. Now again, you have to find network address. For the first one, this one I computed for you is 150, 160, 00. For the second one also is 150, 160, 00. So they have the same network address so they can communicate, right? Is this okay? Is this okay? Yes. Now, has we completed everything now in the tutorial? Yes or no? Confirm. You see, my daughter is waiting alone. There is a road which is not well frequented, right? So I'm a bit fearful, you know, what type of people nowadays there are, right? Is it okay? Completed. So, okay. Thanks everybody for attending, right? We took some time. We completed everything. So, farewell, okay? So, don't forget to complete your lab by next. The lab maybe I will do, if Wednesday is a holiday, I will schedule Friday morning, right? So, the test is Friday again, you have to do. If no public holiday on Wednesday, we will do the lab on Wednesday itself, right? Those who have not shown me the work, okay? Okay. Au revoir, hein? Allez, bye. Don't forget the winner attendance sheet, which I will post later by email. You just fill in your credentials there. Now, good evening, everybody. So, we had to differ, right?
Bonjour, monsieur.
Well, good morning, good evening. I had to differ the time, right, marginally because you see, I was doing an election before another online thing, which got delayed, right? Now, just give me 2 minutes. Let others join. Tell others to join because this is important. Tutorial is important, right? So then we will correct it. Just give me 2 minutes, right? Because I've just come. Right. Just give me 2 minutes. Now, okay. So let's start straight away with the correction of the tutorials, okay? So, now the first one, you see, I've got divergent answers from students, so I've worked it out myself, so I will give you the answers, right? And you please tell me whether, now, in fact, the host ID you need to underline, right? The network ID you have to write, host ID you write the IP address and underline it. Now, I won't underline it, I will just tell you the value. Now, check along with me whether it's okay. So this is the first question. Is it okay? But the host ID, you should write the IP address and then underline it. It's not written like this, right? Because I can't draw here, this is why I've written it this way. You write the IP address and underline. Network ID, you can always write the value. This you can, it's allowed to write. Host ID, you should write this and then underline this part. And then underline the part which is host ID. Is it okay? Or have you done at least or not?
Oui, monsieur.
Wait. Now, look, if you don't do, that's your problem. You see? Right? Don't think this module is theoretical. Eh? Last year, the average was 48. Right? So bear this in mind. And there were many failures, and I think in your batch there was only one A. The others get C and B. And then some D and some failures. Right? So you should attempt. Is it okay? Check against your answer quickly, because we have to complete this. I have other work to do.
Oui, monsieur, correct.
No, just type yes on the chat panel, everybody who has done. Right, okay, now it's okay. Now, you see, because I got divergent answers, so the second question also I will paste the answer because I got multitude of not exactly the same answer, so I said let me try it myself. Now for A is class B, then for B is class A, and then C. Right? This is very easy because right? You see the number of what 255 that you have. 2255 in the first one is class B. The second one is single 255. This is default. What value makes it default is 1255 is A. Right. Okay. Now the third question, right? CIDR notation. You have to convert the subnet mask into bits. Now 255 is 8 bits. 255 is 8 bits. The first one, 224. This one you have to convert. Right? It's 3 bits and all zeros. Right? So 8 plus 8, 16 plus 3 here. Don't count the zeros. Right? It's 19. Right? So I work out the answer myself because you see some students gave me one, some others gave me other answers. So there was a confusion which one is right. So this one I've tested using an application which I've built and I'm 100% it's right. Now check. Okay? Yes. Good. Now, you are math people, you will do it well. Now, broadcast address, right? This you have to work out. You know how to work out? You take 256 in the first one, you minus the value which makes the subnet mask non-default, right? Then you do multiples. Then you should take one which is higher than this. That's the second value here, 50. Then you minus one, right? You know this. I told you how to do this. I did this in lecture. So check whether it's right. I don't know. No, I know that it is right because I've tested it with the software, with an application that I have. Yes? Okay. Okay, that's good. Now the third one. Now the third one, I will spell it out, right? Network address, you know how to do, right? It's a logical AND operation between IP address and subnet mask. Now, when you have 255, it will stay the same. When you have 0, it will become 0, right? So the first one is 54 and then 3 zeros. The second one, this one you have to do, right? 149 and 248 you have to do. So it's 24, 144, 00. Third one, 132, 94, 00. Fourth, 187, 187. Give me 1 second. Hundred and 87, 201, 156, 0. Fifth, 213, 67, 38, 0. Right? Sixth, 220, 182, 5, 24. Is it okay? Yes? Okay. No, I'm 100% sure this one because I have an application that I've built, a small one, to work out this, right? So I use the application and I compute it, right? It should be right. Now, this question 6 is based on network address, right? Stations who have the same network address are able to communicate, right? So you should work out again the network address here, right? So network address for station A is 200, 150, 64. For B, 200, 150, 0. For C, 200, 150, 128. And then for D, 200, 150, 0. So only B and D can communicate because they have the same network address. Is this right? Now, just not only right, I hope you have done it. You see, you should practice. If you don't practice, don't think this module is easy. I'm telling you, last year's average for your batch was, I think, 47. Not even above 50. Right? Because, you know, the student was too confident. They thought it's a theoretical module. It's very easy. It's not easy at all. I'm making it maybe understandable to you and easy. Right? But it's not an easy thing. Module. Now, okay, this is okay. Now, let's do the second tutorial now. Now,
Monsieur, il reste des questions dans le tutoriel. Allez.
ah, il est encodé? Ah, on est en bas, là. Okay, okay.
Les compagnies là.
Oh, okay. I didn't see. Okay, let's see. Okay, it's down there. I thought it was 1, 2. So, company A uses this, and the number of hubs. Now, what is the subnet mask, right? You have 18 last bits. So, the last bit are zeros. So, you should start from the right and write 0. So, it will be 255. Subnet mask is this one also I didn't. All right, so this will be the subnet mask with zeros, 18 zeros at the left. So number of hosts per subnet is 2 to the power of 18 minus 2. This we know, right? Is the number of host bits, last bits. Number, host bit is 6, number of subnet is 2 to the power of 6, 2 to the power of 6 is how much? 64, no? And the subnet mask, which is non-default here, is 255, 25200. Is it okay? Subnet mask is this? Right, okay, good. Now, the second part is a university has this, they have 3 host bit used, find the number of subnets. This is 2 is the number of subnets, 2 to the power of 3, 8. Right? Now, you have to write the subnet mask. The subnet mask will be 255, 255, 31, and the rest zeros. So how many zeros are left is 13. So number of hosts per subnet is 2 to the power of 13 minus 2. You can leave it as like that, and you don't need to simplify it. Okay? Small values you can simplify, large values just leave it like that. I won't penalize you. Right, so the subnet mask, so we won't say default or non-default. right? Subnet mask is 224. Now, free give 224, 100%. Is it okay? Okay, good. Now, the last question is again based on network address. So network address for laptop A is 150.160.0.0. And for laptop B also is 150.160.0.0. They have the same network address, so they can communicate. Is it okay? Right? Okay? Yes? They have the same network address here. Okay. So let's move to tutorial 2. Now, this one is a bit... So assume that the lecture are in on server. State giving reasons as to why uploading and downloading these lecture notes using TCP would ensure good performance. Now, what do you say? Don't just write the properties of TCP. It's not good to write that, right? Don't just write was it sequence or whatever. No, sequence has nothing to do here. Pick up the properties of TCP, which is applicable here. So write whatever you want. Just write one word, for example, flow control or whatever you want. Acknowledgement or... No. It can't provide accuracy of the lecture notes. No. This is the lecture material depends on the lecturer. If he does something wrong, he explains something wrong, or he gives a theory which is wrong, then he's at fault. No. The packets, yes, not the lecture materials. What else? You see, what you have to say here is that TCP enforces flow control because you're downloading from a server. The server is fast. Your machine is a slow laptop. It's not as powerful as a server. So it enforces flow control, right? Right. If a packet is lost, right? If something is lost, it is a packet or data is lost, right? When data is received, it is acknowledged. And when it is lost, it is retransmitted. So it ensures that you get everything, right? Now, one thing you could say also is that resources such as bandwidth, buffer space, routers, CPU cycles are reserved, right? So you have good performance, definitely. Now, question 2, explain giving reasons as to why frame relay is considered to be more efficient. This is straight from lecture notes, right? Because frame relay supports, right, new technological advances such as fiber optic and pure digital transmission end-to-end, right? That is, from you to the destination, right? It's digital, right? So it also eliminates error correction and flow control. These are necessary, these are needed, when you have all technologies and protocols, right? But if you use fiber optic, there will no need for error correction and flow control because it will be very fast line. Now, this question 3 is a very, very beautiful question, right? Who can tell me the answer? This is a bit based on reasoning. It's not something that that is from textbook or whatever. It's purely reasoning. You see, definitely you will use the, yes. Yes, Morgan Tivalen. Hey, Morgan Tivalen, are you a year 4 or year 3 student?
Year 3.
Are you free?
Year 3.
No, that's good. That's good. You are giving good answers. Right? I'm very happy. Right? Now, definitely, you see, you remember we did electromagnetic waves, right? Each radio wave uses a frequency spectrum or frequency band or range, as you want to say. These are just the same thing, right? Maritime communication uses another frequency, right? Satellite communication, another frequency, right? UTP uses a frequency, fiber optic uses a very high frequency, right? So because they have different frequency range, right? For example, you tune to best, suppose Top FM uses frequency 84 megahertz. You tune to 85, you won't get it. Suppose you're using 85, you tune to 85 or 90, you won't get it. You should use the same. So here, one is transmitting on other frequencies, the other is receiving on other frequencies. It won't work. It won't work because of the difference in frequency range or spectrum. Oh, right. This is good. Now validate the correctness and incorrectness from the public, right? Now you see, a system is fault tolerant if it continues to operate even in the event of the failure, right? Who can give me an example of a system, anything which is fault tolerant? That is, it will operate even if one thing is wrong there, one component has gone down. Something that you use every day. Some of you may have it at home. No, I don't want this. No, you're going too far. UTP, no. I want something in practical life, not related to computer science. Fault tolerant, not networking, something else. A car. You take a car, the headlight is down. Will it work? Yes, it will work. Right? Suppose the air conditioning system is down. Will it operate? Yes. The car is fault tolerant, right? So is the one of the doors, the knob is broken. Will it work? Yes, it will work. You can't open the door, but it will still work, right? Now, let's go to the question itself. Validate the correctness of a paper. Now, is it correct first or incorrect? The code from the research paper. Is it correct or incorrect? First thing. Type, please participate, type on the chat panel. I don't want this to be one-man show here. Yes, it is correct, 100% correct, right? Now, you see, here to explain this, you have to explain a bit about, connection-oriented, right? In connection-oriented, a path is established from sender to destination, right? Then data is transmitted, then resources such as bandwidth, CPU cycles, buffer space is reserved on the path, right? And all data are transmitted on this path and it's known as a virtual circuit. Now, if during transmission there is a problem, where link is broken, the router is down, right? Then the virtual circuit is destroyed. It won't operate, right? Because it needs one path of a line less, right? Connectionless packets are sent one after the other, and the router takes a new decision for where to send it for each packet. You see? Suppose you have a picture which is sent. It contains 25 packets. These 25 packets, suppose they are going.